So hi guys, hi everyone. So in today's session we are going to discuss about OSPF. So what is OSPF and the features of the OSPF and the functionalities of the OSPF. So because in dynamic routing, see generally in routing protocols we have different routing protocols, right? Static routing, dynamic routing and default routing. In dynamic routing protocol again we have a IGP, interior gateway routing protocol and exterior gateway routing protocol. Right. So in IGP routing protocol, interior gateway routing protocol, we have RIP, EIGRP, OSPF. So in today's class, we are going to discuss about OSPF. What is OSPF and how it is going to be work, right? So the OSPF generally, guys. So what is OSPF and the functionalities and the features of the OSPF? So today we are going to do the quick review about the OSPF. So what is OSPF? OSPF stands for Open Shortest Path First. So so every dynamic routing protocol will have some like right. So the algorithm it is going to be used the algorithm. So likewise, OSPF is going to be used the SPF algorithm. SPF algorithm. SPF stands for shortest path first. Shortest path first, and it's a link state routing protocol. So OSPF is what? It's a link state routing. It's a link state routing protocol. Link state routing protocol. So in which scenario the OSPF, like how the OSPF is going to be used the SPF algorithm. So consider you have a router one, like this is your router one, and here you have a router two, router three, and router four. So if you have multiple paths to reach the same destination, if you have multiple paths to reach the same destination, then OSPF is going to be calculate which is the nearest or which is the best path. So that path is going to be stored in the routing table. So this is our source, and here behind the router 4 we have the destination. We have the destination. To reach from this router, like from R1, we have two ways. Like we can go via R2 or else we can go via R3 as well. So in this scenario, the OSPF, if you configure the OSPF here, right? So in all the routers, OSPF, here also OSPF. So here also OSPF, all the routers are neighbor to each other. So here the OSPF, like the router one is going to be calculate the SPF algorithm. So which is the nearest path, that path is going to become your primary path. So in this scenario, it is going to be run the SPF algorithm to calculate calculate the best path towards the destination. If you have multiple paths towards the destination, right, to reach the same destination, if you have multiple paths, at that scenario, router 1 is going to be run the SPF algorithm in router 1 and it is going to be calculate the cost. It is going to be calculate the cost, right? In the fourth point, it's a link state routing protocol once again, and OSPF is going to be support. OSPF is going to be support for FLSM as well as VLSM. So here FLSM stands for fixed length subnet mask and VLSM stands for variable length subnet mask. As well, it is going to be support for CIDR, classless interdomain routing, classless interdomain routing. And in the fifth point, we have like OSPF is a classless routing protocol. OSPF is a classless routing protocol. So in dynamic routing protocol, so we discussed earlier also, right? In dynamic routing protocol, right? In dynamic routing protocol, we have a IGP and EGP. IGP and EGP. The IGP routing protocols are RIP, EIGRP, OSPF, or ISIS. So these are all going to be support for classless routing protocol except RIP version 1. So RIP version 1 is going to be support as a classful routing protocol. So that's why IEEE was invented, like RIP version 1 to version 2. So RIP version 2 is going to support your classless routing protocol. Likewise OSPF will also going to support for a classless routing protocol. So we have every dynamic routing protocol will have some kind of administrative distance, right? So the AD value, the administrative distance of OSPF is 110. The administrative distance of the OSPF is 110. And we have the hello timer and the dead timer. So in OSPF, we have a hello timer, the default hello timer, and the dead, or you can call as a hold on timer as well. The hello timer is the 10 seconds and the hold on timer is 40 seconds, which means if you configure here OSPF between here in the between both the routers, so the router 1 is going to be send the hello message, router 1 is going to send the hello message, and the router 2 will also going to reply the same hello message. So every 10 seconds, router 1 is going to initiate the hello messages towards the OSPF configured neighbors. And the OSPF advantage is, guys, and one more thing is, so in hop count, so if you consider the hop count, right, the RIP is having the limitations, right, in the hop counts. When we are going to configure the RIP between these routers, so it is going to be carry your packet till from 0 to 15 hops only. But if you configure the EAGRP, so the default hop count in the EAGRP is 100 routers, right, 100 hops. We can maximize this till 255. Likewise, but in OSPF we have an unlimited hop count, unlimited hops. So there is no concept of hop count and all. So likewise, the metric. So the ninth point is like the metric. What is the metric of OSPF? So in OSPF, metric is equal to cost. So the cost of the link. What is the cost of this link? So if I go like this, what is the cost? So every link will have a cost. So when it is going to be run the SPF algorithm towards this direction and this direction, it is going to calculate the cost. So whichever the cost, like if I go via router 2, if the cost is less, then that route is going to be become as your best router, the primary route. So this is what the points, as a few of the functionalities are, you can call as a future of the OSPF routing protocol. Open shortest path first. And one more thing, like, so as it is a open standard, right? So OSPF is the open standard. So what is the RFC number? In few interviews, they are going to ask you, so as it is a open standard, then what is the RFC number? So the OSPF RFC number is, as an open standard, 2328 and RFC 2740. This is the standard, like the RFC open standard one. So, and one more thing, guys, so the OSPF, when the OSPF packet is traveling, right, it is going to be add the protocol number as well, protocol ID, as the OSPF protocol ID is 89. OSPF protocol ID is 89. So we cover almost all, like, and the very interesting thing here is, so when you use the EAGRP here, right, so it is going to be do the equal and unequal cost load balancing, but the OSPF will not support for unequal cost load balancing. So till now we covered a few of the functionalities of the OSPF. So even in interview also you can call as a, what is OSPF? If interviewer asks, like, tell me about OSPF and explain about the OSPF. So start from here, like OSPF stands for open shortest path first. OSPF stands for open shortest path first. It is going to be used the SPF algorithm to calculate the best path. SPF stands for shortest path first, and OSPF is the link state routing protocol, and it is going to be support FLSM, fixed length subnet mask, VLSM, variable length subnet mask, as well as CIDR, classless interdomain routing, and OSPF is the classless routing protocol. As we have the administrative distance for each and every dynamic routing protocol, even we have the static routing AD value is 1. Likewise, OSPF will have a AD value 110. OSPF will have a AD value 110. And the hello timer and the dead timer is, the hello timer is 10 seconds and the dead timer is 40 seconds. The best thing here is in OSPF we don't have a unlimited hop count. We don't have any like concept related to the hop count. So many only for this many hops it is going to carry your packet. So in OSPF metric equals to cost. So the cost is like the link cost. Whatever the link you are going to use, that link is having the cost actually, right? So that link is having the cost, guys. Now, and OSPF is the open standard protocol. So the RFC number is 2328 and 2740. OSPF protocol ID is a protocol number. You can say as a protocol ID or protocol number for in IP header. Where you are going to see this 89, you are going to see is this 89 port number like the protocol ID in the IP header, guys. In the IP header. So where exactly IP header? What is IP header, Ethernet header, and the TCP IP header, which we already covered and we posted in our YouTube channel as well. You just go through with those videos and you will get to know. So now I just taken a small example here. So this is our WAN, and here we have a LAN, WAN and LAN. So you can consider in this R1's LAN, this is our R1 router. In the R1's LAN, we are going to use 1.0/24 network. In the R2's LAN, we are going to use 2.0/24 network. So without doing the routing, the communication will not be possible, will not be happen between both the LANs. So once you perform your basic configuration here, like the basic configuration, then you need to configure must and should any dynamic routing protocol or any static routing. Like you need to do the routing. So in today's our example, we are going to do our OSPF open shortest path first. So you can do the OSPF and we can introduce the subnets, the behind backend subnets, whatever the subnets we have here, right? In the backend we have 1.0/24 subnet. In the WAN side we can take one of the subnet 172.16.1.0/30 we can consider, okay, because we will get the 4 IP addresses, right? One will be the network ID and the other one is the broadcast ID. So we'll get 1.1 here and 1.2 here. So this is what the functionalities of the OSPF, right? The functionalities of the OSPF. Now, guys, in OSPF we have a concept of router ID. We have a concept of router ID. What is router ID? So in every interview they are going to ask you what is router ID. So router ID is used to identify the routers in OSPF. Router ID is going to be used to identify the router ID. Actually, see, in scenario is if you have a router 1 here, which is connected towards your router 2, and even we have a router 3 here, which all are connected, right? So here we have a 172.16.1.1. Here we have a 172.16.1.2. We'll take /30 subnet so that we don't want to be waste our IP addresses. So here we will take 172.17.1.1/30. Here 1.2/30. In this one we will take like 172.18.1.1/30. Here 1.2/30. See now what will happen. So once you enable the OSPF in all the routers, once you are going to enable the OSPF in all the routers, so it is going to be send the hello message, right? It is going to send the hello message towards R1 and R2, R1 and R3. So R1 is going to send the hello message towards R2 and R3. So how this router is going to be identified? And this R2 is also going to send the hello message to the R3. So R1 router will get 2 hello messages and R2 will get 2 hello messages and R3 will also get the 2 hello messages. So how the respective router is going to identify from which router did I get the hello message? So for that in OSPF we have a concept of router ID. So the very first point even in the interview you need to be explained. If the interviewer asks you, right, what is router ID? So you can mention this point. The first point is even we call as a RID also, guys, in BGP. So the router ID used to be called as a RID. So router ID is used to identify a router in OSPF. So this is the first point you can mention. And to calculate the router ID, okay, to calculate the router ID. See, so which one is you are going to be calculate, right? Router ID. Who will become your router ID? Will, so what will become your router ID? So to calculate the router ID, right? So there are few conditions, guys. So there are few conditions. The very first condition is, right, the very first condition. So if you manually configure router ID, that is going to be give the highest preference. So the first preference is going to give the manually configured RID, the manually configured RID, and the second preference is going to give the highest loopback address, and the third preference is going to give the highest physical IP address, highest physical address, highest physical address. So in OSPF, so the router ID concept is going to identify the router, right? So router ID is going to be used to identify the router. So to become the router ID, there are three criteria. So the first criteria for the very first thing is we need to be manually configure the router ID. This is going to be configured. This is going to be given as a highest priority as a manually configured router ID. If you don't configure here, that if you don't configure manually the router ID, then it is going to give the second preference to the highest configured loopback address. So what is loopback now here? Again, the question is, what is loopback? Well, loopback is is nothing but the logical interface. So this interfaces we are going to call as a physical interfaces, right? This is our physical interfaces, which are connected with all the routers. So these are our physical interfaces. So the loopback interface or the virtual, you can call as a logical interface, loopback interface or a logical interface. I'll take my screen a bit up. Okay. You can call as a loopback interface or logical interface or logical interface. So the second preference is going to give this one, like the loopback interface or the logical interface. So this is going to be reside inside your router. This is going to be reside inside your router. So whatever the interfaces you are going to configure, right? So logically it is going to be inside your router. So likewise, how we are going to configure the physical interface? The same thing we need to be configured. The same way we need to be configured here. So you need to enter into the global configuration mode, then interface loopback. You can give the any number. So I'll give loopback 10. Then we need to assign the IP address for this particular interface. So the IP followed by the IP and the subnet mask. So we need not to use the no shutdown command because as it is a virtual interface. So once you enter this command, right, interface loopback 10. Okay, so it is going to be manually come up, like it will by default it will be up. Only for the physical interfaces we need to be used the no shutdown command, only for the physical interface. Whenever the physical interface you are going to assign the IP address, on that scenario you need to assign manually, you need to configure manually the no shutdown command, because the physical interfaces are by default shut down, but the logical interfaces, the loopback interfaces are. So once you enter this command, right, interface loopback 10, it is going to be up or turn up automatically. So this is what the router ID configure, like router ID in the OSPF. So if you want to configure the router ID in the OSPF, so you just need to be enter into the configuration of the OSPF, like router OSPF and the process ID. Then the command is router-id. So then you need to be enter the router ID. So this router ID, see whatever the ID you are going to assign here, right, it's a 32-bit of address, guys. It's a 32 bit of address. Even in the interview, it is going to be, so the interviewer is going to ask you the crash question. So if you are going to assign the IP, like the router ID, right? So what is the length of that router ID? So it's a 32 bit of, it's a 32 bit. Okay. Hope it is clear the router ID concept. Now, in every dynamic routing protocol, so if you take the RIP or EIGRP or the OSPF, every routing protocol are going to be maintained few of the tables, right? Once you configure the OSPF or the once you configure the any dynamic routing protocol, so it is going to be exchange their networks, the backend networks, and it is going to be maintain few information. So OSPF is going to maintain the three tables. The very first table is neighbor table. And the second one is topology table. The third one is routing table. I'll draw the topology so that you will get to understand. Okay. So here we have a router 1 which is connected towards our router 2, and router 1 and router 2 both are going to connect with the router 3. So every routers behind we have a LAN network. Even in router 2 also we have a LAN network. The below of router 3 will also have a LAN network. So to form the neighborship, the few of the conditions has to be matched. So router 1 and router 2 can able to form the neighborship because both the routers are going to share the same interface, and here it is going to be share the same kind of like the subnet, same kind of the network. So then only it is going to form the neighborship. So consider, so router 1 is directly connected with router 2 as well as router 3, right? So in router 1 you can see, in router 1 you can see that if you check the routing table, like if you check the neighbor table, right, in router 1 you will see router 2 and router 3 as the neighbor of router 1, because the both the routers are going to be, both the routers are connected directly, right? Connected directly, and the router 1 is going to become the neighbor, router 2 and router 3 is going to become the neighbor of router 1. So if you check in the router 3, guys, if you check in the router 3, router 1 and router 2 will become the neighbors to router 3. The likewise in router 2 you will have the neighborship with R1 and R3. So because every router is connected with each other, so every router will have a two neighborships. Every router will have a two neighborship. So in neighbor table, generally in neighbor table, what information it is going to be maintained, right? It is going to be maintain the directly connected neighbors information. It is going to maintain the directly connected neighbors information. So that's why I mentioned here in the router 1, you will see the neighborship of router 2 and router 3 because it is directly connected. Consider if you have a router 4 here which is connected towards router 2, in router 1 you will not able to see here. If you have a router 4 here which is connected towards R2, right? So in this scenario also you are going to see only your neighbors as a directly connected router 2 and router 3. You will not able to form the neighborship with this indirectly connected router 4. So there are some conditions or few conditions we have, like to form the neighborship, all the routers has to be connected directly. All the routers has to be connected directly. Then only we can form the neighborship. So the neighbor table is going to maintain the information of directly connected neighbor routers information. Right. In the topology table, so what will happen in the topology table?
Hello.
Yes,
Previously, you were briefly explaining tables in OSPF, but you told database table, neighbor table, database table, routing table.
yeah. So in EAJIP, we are going to use the database table. So database and topology both are same, but
Okay.
here in the topology table, so what will happen, right? The complete information of the topology will be have the information. We'll have the complete topology information in the topology table. But in EAJIP, so when you are going to study the EAJIP, right? So in EAJIP, it is going to maintain the neighbor table, database table, and the routing table information. But in OSPF, we can call as the same kind of database table as a topology table. But
Okay.
scenario
Database
is same.
table and topology table are both are same.
Yeah, both are same. You can mention here like the database or topology table or the database. The work is same. The work is same, which means it will contain. So the router one will contain the whole information of the topology, which will include the router four, router two, and router three information in the router one. Okay.
Oh,
So in the routing table, see, sometime before we discuss, right? If you have a multiple paths to reach the same destination, here likewise, where we have discussed here, yeah. So if you have a multiple paths to reach the destination, like if you have a multiple paths to reach the destination, your OSPF is going to be run here SPF, shortest path first algorithm. So whichever the path is having the low cost, the low cost, that path is going to become your primary path. That path is going to become your primary path, right? So that path is going to be primary path, and that path is going to be installed in your routing table. So in general, the network table is going to maintain your directly connected network information, right? And in the topology table or the database table is going to maintain your whole topology information. It is going to be see, it is going to be view on the top view. Top view means you can see all the routers, like including in R1's topology and database table, you can see all the routers information in the routing table. In the routing table, so we have the two ways to reach R2's LAN. So whichever the best one, so that is going to be installed in the routing table. Now in interview, they are going to ask you one more thing, like see how you are going to check the, how you are going to check the tables, like respective tables. So you have a three tables, right? What is the commands to check the different tables? To check the neighbor table, the command is show IP OSPF neighbor. Show IP OSPF neighbor. So with the help of this command, when you are running on the privilege mode, so you can able to see, if you run this command in the router one, so you will see that your R2 and R3 will become the neighbor, right? So likewise, to check the database table, the command is show IP OSPF database. Show IP OSPF database. If you want to check your routing table, right? So the command is show IP route, or else specifically if you check this command, right, show IP route, it is going to show you complete routing table. If you want to check only the OSPF routes, then you can filter the command as well. Show IP route, the pipe symbol, right, include OSPF, you will get only the OSPF routes. So when you check the routing table, right, there you are going to get the route as a O. O stands for OSPF. O stands for OSPF. And one more thing, you used to get OIA, OSPF inter area routes, OE1 and OE2. That we are going to discuss in another session. But in generally, if you have configured the OSPF in a single area, then you are going to get the routes as a OSPF. So to reach this particular destination, we are learn the route from the OSPF. It used to identify it as a OSPF. Now, so what is the advantage? Like, see, what is the advantage of the OSPF? Advantage of to running the OSPF in our infrastructure. What is the main advantage? So even that also going to be discussed in the interview. So the importance of the OSPF, if you ask me, right, the fast convergence. Like you can advantages of the OSPF. So it is going to be do the fast conversation. So I'll mention this point. Sorry, fast conversation, fast convergence, and scalability. And the third one is like the load balancing. And the security as well. And security as well. So you can mention these points when the interviewer asks it. So compare like what is the advantage between the EIGRP and OSPF. So every routing protocol will have their own features and the functionalities. So if you are going to use the OSPF, so OSPF is, as it is an open standard, right? Open standard routing protocol. We can configure in any OEM product, like any OEM device, original equipment, manufactured device. So if you are going to configure the OSPF between the in your organization, so it is going to be have a fast conversation and the scalability, load balancing, and the security. So for the fast conversation means it is going to be convert like very efficient and can converge quickly. Means if any changes occur, like any changes occur in the network can be detected and respond very quickly. So that's why we used to call as a fast convergence. And scalability means, so in OSPF guys, it is going to be used the hierarchical network. In OSPF, we are going to use the hierarchical design. So hierarchical design in OSPF. So but in EHIP we will not use the hierarchical design. If you have 100 routers, you need to be configured. You need to set in a same like the process ID. But in OSPF there is a concept of areas, right? Area concept we have in the OSPF. So we can place the different like routers in the different areas. So due to which we can call as a hierarchical design. It supports area which can use as a divided into large network into a smaller pieces of the like the areas. It helps to reduce the so multiple things like we can like reduce the CPU utilization because we need to the router needs to be run the SPF algorithm, right? Shortest path algorithm. So when the router is going to be run the shortest path algorithm towards the destination, whichever the destination you have, like if you have multiple routes to reach this particular network, if you have multiple routes to reach the particular network, the router is the R1 used to be run the multiple times the SPF algorithm. If it is going to be run the multiple times SPF algorithm, it is going to be calculate the CPU, that it is going to consume the CPU and the memory as well. So if you want to reduce this the high utilization, then you can use the hierarchical design. So like you can divide your network based on the area. So the CPU utilization and the multiple times running the SPF algorithm is going to be reduced. And the load balancing. So as we discussed earlier, also like the OSPF supports multiple paths to a destination network. Like if you have a multiple paths to reach the particular destination, so it is going to be do the load balancing, but it is going to do only the equal cost load balancing. That you need to be remember, guys. It is going to do the equal cost load balancing, whereas EAGRP is going to support equal and unequal cost load balancing. The security is the best feature in OSPF. We have a security concept like it's going to support the authentication. It is going to support the authentication. So where we can use the plain text authentication, or we can use the MD5 authentication. Because if you have a two routers like router 1 and router 2 which are sharing the same link, if you configure here the authentication, the same authentication has to be matched here also, then only it is going to form the neighborship, or else it is not going to form the neighborship. So this is what your advantages and the disadvantages of the OSPF. And we discuss about the router ID as well, right? So and one more thing, in OSPF we have a neighbor states. So let me deal about that as well.